I'm going to look here is area 2 first. Let's look at this. That's the area that we want to find. But right now, we don't have any way to do that. But if we examine this, we do know that area, don't we? What's that area?
The area of fx minus the area of g.
I'm looking for just the green.
Oh.
Get into that one yet.
Oh, okay.
What is the area of that green shaded region?
Definite integral of g to x, the g of x from a to b.
But then that yellow striped area, we know that as well, don't we? What's that area?
The integral of fx. Maybe.
Should. Well, if you now look at that blue shaded region, can't we just take the yellow region and remove the green? So just kind of cut out the green and we're left with the blue, right? Remember in geometry when you were finding areas, you would sometimes do that. Like, for instance, you want that area, how would you find it?
Take the area of the circle and the rectangle and subtract the area of the square.
Area of the what?
Oh, sorry, just area of the circle minus area of the square.
Square.
Rectangle. Area of the circle minus area of the rectangle. Sorry, it's been a long week. It's Tuesday, I know. I had an exam yesterday. Yeah. Student.
We'll go back and rewrite the calculus.
To make it easier or harder?
Hard.
Oh. Okay.
It's gonna be the same kind of thing here. So it'll be the area of that larger region minus the area of that smaller region, right? But remember what we know about integrals. They're linear. So this is how we would find the area between two curves. But notice the stipulation here. F of x had to be greater than equal to g of x over that entire interval. What if that's not the case?
That's right.
If they cross each other, it's just the absolute value. You know what? That's kind of boring. if I'm not interested in that region. Or, I can make it even more interesting, this region. A region such as that is said to be defined with vertical slices. Well, then this region will be defined, both those regions actually, you can define horizontally. This one means you set functions of y instead of x. Same thing, except now it's functions of y instead of x. Oh, theologians are not as nice there. That's okay. We want the area between 4 minus y equals 4 minus x squared and y equals 0.
So, I don't know if this is the best strategy, but it makes more sense for me. I'm just wondering if this is like a legal move in math. Can you just swap x and y in the problem and it's effectively the same thing, flipped across the, why not?
Do that here.
That's x equals 4 minus y squared. And
Is
x
that the
equals
same
0.
thing?
No, but if you're looking for the area between.
Still not. You have to be careful. You can't just do that.
Okay.
Because x would be positive or negative. You have to look at the region.
Oh, okay.
In fact, x equals 4 minus y squared is completely different than y equals 4 minus x squared. X equals 4 minus y squared would be a parabola rotated. This is a parabola the right way. So those are two different graphs.
Okay.
You'd have to solve for x,
Okay.
which you can do, but again, be careful because this will give you plus or minus. And so 4 minus x squared make sure it's somewhat symmetric. That's good enough. That'll be 4 minus x squared. What's y equals 0?
X-axis.
So the region that we want That's the area we want. Right. Let's get rid of this. It's red to the percent. But what we need, right, are those two limits, x1 and x2. How do you find them? How do we find x1 and x2?
You set it equal to 0.
Set what equals 0?
Set 4 minus x squared equal to 0.
So what's x1?
-2,
What's x2?
+2.
You now need to determine what the upper bound of the region is. This one's pretty obvious. But algebraically, what would you do? Well, you know what the interval is, right? -2, +2. Pick a point in there. The easiest number is in that interval, isn't it? Take that to second. Plug 0 back into each function. You get 4 and 0, right? Which one's larger?
4.
So 4 minus x squared is your upper bound. That would be the area. No, but that's easy because that is just the integral of 4 minus x squared dx. Right? How do we evaluate that?
First, we have to find the integrated root.
What's the theorem?
Oh man, I just do this. It's like capital FB minus capital FA.
No, what's the theorem called?
Oh. The fundamental theory of calculus?
Fundamental what?
I forgot. Fundamental calculus theory.
Fundamental theorem of calculus. It's only the most important theorem of the semester. I forgot its name.
I know what 3 I have.
10 points from Gryffindor. Oh, you have Slytherin. Okay, how do you? 15 points to Slytherin. So it says that big F B minus what's big F? Not for this problem, in general. Be careful. Not the antiderivative. That implies that there's only one.
Not antiderivative.
And antiderivative, any antiderivative of the function. Which one do we take?
The one where c equals 0.
which is called the simple antiderivative. What is our antiderivative?
4x minus 3x cubed over 3.
That would just be x cubed.
Oh, x cubed over 3, sorry.
Two minus negative two is what?
4.
Times 4.
16.
What's 2 cubed?
8.
What's negative 2 cubed?
Negative 8.
8 minus negative 8.
16.
Now what is 16 minus 16 thirds?
Seven two-thirds?
We don't ever use mixed numbers in that.
Oh, sorry. So 32 over 3.
Thirty-two thirds is the area. By the way, there was an easier way of building this. Isn't 4 minus x squared symmetric about the y-axis? That means that region will be symmetric about the y-axis, right? Means the two areas are equal. You're just integrated from 0 to 2 and then double the result. Symmetry is going to be a very important role in Calc 2 and Calc 3. So get used to looking for it now. More symmetric now. And x plus 2. Probably something like that, right? That's the area we're looking for, right? What happened there? That was weird. Why is it doing that? I don't know why replace that color. We need X1 and X2. How do we find them?
It's like the functions equal to each other.
Can that be factored with integer coefficients?
Yes.
What is the factor for?
X minus 2, x plus 1.
What's X1?
Negative 1.
What's X2?
2.
Over that interval, which is the upper bound function.
X plus 2.
There's how the area would be found. That's the area, right? What's the antiderivative we're going to be using?
Uh, 2x plus x squared over 2 minus 3x over 3. Or, I'm sorry, x cubed over 3.
Two minus negative 1
3.
times 2.
6.
2 squared,
4.
negative 1 squared.
1.
4 minus 1,
3.
half of 3.
3 halves.
2 cubed, negative 1 cubed.
Negative 1
8 minus negative 1
is 9.
divided by 3.
3
6 minus 3
is 3.
plus 3 halves.
8 halves? No. Sorry, I don't know why I got this. 9 halves.
There's the area.
I think we should use symmetry for this one. That way we don't need to split absolute value of x into a piecewise function.
gonna wind up doing both. So we can actually use Wolfram to give us the shaded region. I'm gonna call this plot one for now. You can plot multiple functions on the same axis as long as you place them in braces. And it was what, x squared and absolute value of x? That's what the plot range to be the same. We'll see. I don't like Wolfram City as colors, and that should be good. No, that looks very good. Where do they intersect?
One. And a 0.
Technically, yes. In this one.
And a negative.
Yeah, but you can't assume that's the scale. Moment of truth, Lily, right? What do we think?
I hope so.
Uh-oh, I'm shrugging. That's not a good your answer. Very not confident. That means the interval is going to be -1 to +1. I'm going to start the same way, actually. Work smart, not hard. I'm going to copy, paste. Since I know the intervals now, -1 to 1, I'm going to change that. Now I'm going to fill it. And how I want it filled, no real jokes. From curve 1 to curve 2. Give me color. Great. You're so boring.
Oh, that's so great.
You're so boring.
Not boring color.
Yes, it is. You don't have to look at the RGB code. It's boring. Wolfram. That is not green. Green is darker than that. Oh, Wolfram. I can now use a show command. What the show command does is it shows, obviously, images on top of each other. The order in which you list it matters. Wolfram will give priority in descending order of how you list it. So I guess ascending order. You get 1, 2, 3. So the first image you list is top priority, which means everything else will be shown on top of that. I only have two, right? So I want to show plot 2 on top of plot 1. And there's our region. Just copy this. Oh, that's right. We do funky things. Let me actually look at that. Is that cutting it off? No. So we have the integral from -1 to +1. Which one is larger?
Absolute value of x.
What is an antiderivative of absolute value of x? Depends on where we are. We have to split this integral. Over -1 to 0, what is x? Or what is the absolute value of x?
Positive.
From 0 to 1, what is the absolute value of x?
X.
That's how we have to do it. What would the antiderivative of that first one be?
Negative x squared over 2 minus x cubed over 3.
What about the second one?
Same, just positive x squared over 2.
Zero squared. -1 squared. 0 minus 1 times -1/2.
Means 1 half.
0 cubed.
0
-1 cubed.
is -1.
0 minus -1
It's 1,
times -1/3.
so minus 1/3.
What's 1 squared? 0 squared.
0.
1 minus 0 times a half. 1 cubed. 0 cubed. 1 minus 0
1.
times negative a third. Oh, but look at that. Aren't those two areas the same? You could have used symmetry and doubled. We're just pretending like we didn't see it. Half plus a half, a third plus a third,
2/3.
1 minus 2/3.
Is 1/3.
Total area is a third. X equals y squared, and x equals 2y plus 3. Take 90 degrees. That is x equals y squared. 2y plus 3, the slope of positive 2, and x-intercept of 3. There. Slope of 2. So, something like that. Probably. No. No, I should have positive slope. still cross out everything else though. More like. There's the region of interest. Now, what would happen if we try to do it the way that we've been doing it? So imagine vertical slices. Right here, what is the upper limit and what is the lower limit?
The other limit is x equals y squared. And the lower is x equals plus 3.
Vertical, they need to be functions of x. It would be negative root x to positive root x. Now what are the limits? Same thing?
They're both lower.
Slightly to the left. Same thing, right?
Yeah.
Now what is it?
It's y equals negative. Oh, sorry. This is not confusing.
So again, we're only looking at the shaded region. What does the bar extend from?
So then it's y equals x over 2 minus 3 halves.
Oh, that's a different lower limit, isn't it? That's a different lower bound. What we would have to do is do that and consider two separate regions. So you have to sum two areas. But they already gave it in terms of y. So look what happens if we now do horizontal slices instead. Say right here, what is your upper bound and what is your lower bound? So it goes from what to what?
X equals 2y plus 3 is the upper bound, and then x equals y squared is always the lower bound.
Now move that.
The same.
As it moves through that region, does it ever change? So that would be a single integral. In this case, it'd be more convenient to use the horizontal slices for two reasons. One, we don't need to do one area. Two, they already gave us the curves in terms of y. Well, that means we need the points of intersection in terms of y. We need y1 and y2. Wouldn't you just do the same thing? So you have two curves equal to each other and solve. Why did I do 2y squared? Can we factor that with integer coefficients?
No.
Oh. It would help
Oh,
if
it's b minus 3.
it would help if I actually did arithmetic, right?
Yes.
What does it factor to?
Y minus 3, y plus 1.
What's y1?
Negative 1,
What's y2?
3.
What's the integral setup for the area? Yes, over here actually.
So from the integral negative 1 to 3. The integral of 2y plus 3. That's up and down. Minus y squared. dy.
Can we still use fundamental theorem of calculus?
Yeah.
Remember, that y is just a dummy variable. So in fundamental theorem of calculus, it gave it in terms of x, right? But it's a dummy variable. It works no matter what. What's our antiderivative?
3y plus y squared minus y cubed over 3.
That would go from minus 1 to 3. Running out of room, so let's start to arch upwards. 3 minus negative 1
At least 4.
times 3.
It's 12.
3 squared,
It's 9.
negative 1 squared.
This one.
9 minus 1. 3 cubed,
9. Oh my god, it's 27.
negative 1 cubed.
It's negative 1.
27 minus negative 1 times a third. Twenty minus 28 thirds.
52 over 3.
Was it?
32/3.
It should be 32/3. Oh yeah, I think that calculation is wrong. Yeah, 32/3. That would be our area. I am not. So I think here's what I'm going to do for this one. Instead of doing the whole graph, we're just going to spit out the actual region itself, which means first we need an interval, right? It was what, x cubed minus 4x? What was the other one?
-0.
Oh, it's easy at least. Oh, oops. I abort. How do you abort it for me? Thank you. -2 to 2. The fact that there's a third one in there is going to be a hint on what I'm going to be doing.
It's symmetrical again.
I guess we'll find it. So let's just plot that from -2 to +2. Let me not touch the plot range. This time, I only want to fill it with the axis. So it's going to go axis to curve. That's how it's going to fill. What color?
Pink.
Again, another blue color.
Really?
Because pink is stored in more. Oh, pink. Is stored in more from.
What's an exciting color to you? Can you do an exciting color? That's not blue.
They say that's pink.
I don't like
That's
that.
salmon.
That's so.
But I did forget to do this. So let me actually just go up and look up what pink actually should be.
I mean, it's right here.
Colors. Just one regular pink.
Does it?
Alright, well then I'm just gonna do this. Pink. RG. There, that's what I want. Has to be as decimals, it wants proportions from 0 to 1, so it's going to be 1, 0.753. Do I trust that? And 79.6.
That's nice.
Uh, Symmetry is obvious. X cubed minus 4x is odd. Odd functions are symmetrical about the origin. So we're going to look at this positive region and double it. Set up the integral.
From -2 to 0. The integral of x cubed minus 4x. Yes.
Now it's off. What's our antiderivative?
X to the 4th over 4. Minus 2x squared.
Zero to the fourth.
0.
Negative 2 to the fourth.
16.
0 minus 16 divided by 4. 0 squared.
0
Negative 2 squared.
is 4.
0 minus 4
-4.
times 2.
4 times negative 2 raised to b plus 8.
What does that equal?
4 then times 2, so the area goes 8.
Our total area is 8. That's how you find area between curves. And we can get really funky with it. So probably be re-examined too. There's probably going to be a bit of overlap. You might also have low potential. Technically, I'm going to recap it too. So the final homework is due before the final exam. Final exam is on the 16th. That is next Tuesday in this room at 3 o'clock. Unit 4 test is due Monday.
At midnight? Or...
Technically Tuesday at midnight.
Oh, okay.
So by the end of
Okay.
Monday. Solutions will be made available immediately after the due date.
All right.
So Tuesday, you could go back in and look at the solutions, study it before the final. Don't forget, the final is comprehensive. What the game plan is for Thursday. Think of it as a mock exam.
Is it right?
I'm going to give you the review sheet.
Right.
Work in groups. Right, so you can work in your groups. But that review sheet is just like the tests. It's a very good indicator of what the finals could be.
Okay.
I will then have solutions go out at the end of class, so that'll probably go through as a Teams message right after class ends. So again, you can study it. I, of course, won't be collecting the review sheet, right? But you can kind of think of it as the actual final exam itself,
Oh,
because it's going to be a very close read of the books.
oh.
It's really no reason why you failed the final, right?
Sure.